Hi everyone! Our study is about examining discounting on eating behavior for women on their menstrual cycles. This was conducted by Monique Barnett, Brandy Davis, Leslie Hikiana, Jessica Mayhew, and Mina Rohale. Menstrual cycles contribute to the overall health and lifespan of women. During menstrual cycles, women may experience significant increases in appetite, such as craving salty or sugary foods more than normal. While this occurs on a monthly basis, research shows that fluctuating eating habits may cause women to struggle with weight gain or obesity. There are many other contextual factors contributing to weight gain, but engaging in healthy eating behaviors largely prevents the likelihood of becoming overweight or at risk for obesity. Discounting is a means to predict future behavior based on data. Discounting is being used in various ways to examine healthy eating behaviors. For instance, Hendrickson and Rasmussen, 2013, found that there was a correlation between how immediately food was delivered and excessive eating. Additionally, Maddock, in 2004, found that individuals who prefer immediate, less healthy food options may be more likely to be at risk for obesity. Weller, Cox, Afsar, and Cook, 2008, examined discounting patterns with money across obese and healthy weight participants. They found that women who were obese were often more impulsive based on their higher rates of discounting when compared to healthy weighted women. These results were not reflected in the male participants. At this time, we did not find any research specifically investigating eating habits on women during their menstrual cycles. The purpose of our study is to evaluate probabilistic discounting on eating behaviors for women when they are on their menstrual cycles. Upon analyzing results and identifying the best fit equation, we will discuss how various contextual variables influence this data, as well as how our results may be expanded upon in future research. The materials in our study consisted of a computer for the survey, which consisted of 3 parts, the consent form, demographic survey, and discounting questionnaire. We also used GraphPad Prism 7.03, Chocolate to compensate our participants for their time, a task analysis to ensure reliability, a clipboard, and a writing utensil. All participants were recruited at a university campus library. Each location had several tables, chairs, lamps, bookshelves, and televisions. All surveys were completed at the campus library in one sitting. Participants completed all 3 sections of the survey on a researcher's laptop. It took approximately 2 hours to recruit all 15 participants and have each participant fully complete the survey. Each participant completed the survey within about 5 to 10 minutes. Demographics from our participant pool reflected a mean age of 22 years old, ranging from 19 years old to 24 years old. Participants were racially heterogeneous, 40% of the participants identifying as Caucasian, 33.3% identifying as African American, 20% as Hispanic or Latino, and 6.7% as Asian or Pacific Islander. Year in school was identified as 1 freshman, 1 junior, 4 seniors, and 9 graduate students. Of the 15 participants, 86.7% reported that they have regular menstrual cycles, and 53.3% reported that they are currently taking birth control. The median value participants reported for how healthy their diet is while on their menstrual cycle was 3. Given our results, we calculated the linear, exponential, hyperbolic, and hyperboloid discounting functions. Our x-axis was represented by the percent of probability, and our y-axis measured the subjective value. We used these equations to analyze which curve best fits the data. We found that the hyperboloid function best fit our data. Given the hyperboloid function, r squared was 0.7664. The r squared value represents the variance accounted for by the model. This value suggests that the hyperboloid function would allow for a 76% chance to predict y when given an x value. The best fit k was taken from each graph and added to determine our average k value. Our average k value is 0. Area under the curve was calculated to find the discounting rate of participants across identified race. We utilized a scatter plot to show each participant's race and the differences in discounting. Area under the curve was found to be 0.1935. Median values were calculated to determine food values given delays. About 53% chose the delayed preferred item at 10% probability. About 57% chose the delayed preferred item at 30% probability. About 77% chose the delayed preferred item at 50% probability. About 87% chose the delayed preferred item at 60% probability. And 97% chose a delayed preferred food item at 70, 80, 90, and 100% probability. Overall, about half of our participants demonstrated relatively impulsive behavior based on how quickly they chose the probabilistic choice over a definitive choice. Upon completing our study, we identified several limitations. First, we found that our participant pool was significantly low and reflective of a very specific population. Additionally, having such a limited pool limits our ability to accurately derive realistic relations from our results. Another limitation of our study was that all of our questions were hypothetical and participants were not required to be menstruating to partake in the study. Conducting our survey with women on their menstrual cycle using real food may result in different findings. Additionally, we only utilized one form of discounting. Comparing several types, similar to Cox and Dallery 2016, may provide more accurate data regarding discounting on eating behavior. In response to our limitations, our study provides a good basis for future research. It would be interesting to see the results of our study if our participant pool was larger, as well as comparing results across age groups. Klump et al. 2015 reported that hormones during menstrual cycles affect women and adolescents differently. This can result in varying effects of behavior, including eating behavior. Another area of future research would be to examine how our results may change when utilizing multiple forms of discounting. For example, Cox and Dallery 2016 found that simultaneously applying both a delay and probabilistic discounting resulted in overall decreases in choosing the probabilistic choice. A final area of expansion could be to examine how and if treatment can adjust our results. Hendrickson and Rasmussen 2013 found that engaging participants in mindfulness training can help to treat and/or prevent obesity in individuals. It would be interesting to see how this treatment could be applied to impulsivity and discounting. Thanks for watching. Here come our references.